This lesson is based on the textbook Modern Welding, 11th edition. If an alternate edition is used of Modern Welding, you will have to look up the chapter that pertains to the material covered. Chapter 20, Special Ferrous Welding Applications. Objectives. Define low, medium, and high carbon steel, as well as plain carbon steel and alloy steel. Explain when preheat treatment, interpass heating, and post-weld heat treatment are needed, and on what steels. Describe the proper procedures for welding stainless steel. Identify the four groups of stainless steel. Ferrous metals and alloys. Ferrous metals include all varieties of iron alloys and steel. Non-ferrous metals include any metal or alloy that is not composed primarily of iron. The different iron alloys and steels have widely varying properties. Ferrous metals and alloys. Steel is pure iron to which small quantities of carbon are added to provide strength. To obtain special properties in steel, alloying elements are added in various amounts. Welding medium and high carbon steels. The following information must be known to make an acceptable weld: the correct preheat temperature, the proper interpass heating temperature, the proper post-weld heat temperature, the proper welding process and procedure, and the electrode or filler metal to use. Welding steel alloys. Some heat treating is necessary immediately after welding. A post-weld stress-relieving heat treatment is necessary to prevent cracking in the weld and the heat-affected zone. The welded assembly is later heat treated to obtain the desired strength and hardness. Welding chrome-molybdenum steels. Chrome-molybdenum steels, better known as chromoly steels, are relatively corrosion resistant. They are used when strength at high temperatures is required. They are resistant to oxidation and sulfur corrosion. Welding can be done with all arc welding processes. A low hydrogen electrode should be used. Post-weld heat treatment may or may not be necessary. Welding Maraging steel. Maraging steels have high strength, toughness, and good weldability. Martensitic forms when this steel cools from the higher temperature Austenitic phase. Aging increases the strength, toughness, and hardness of the steel. These steels can be arc welded. Stainless steels. A large number of steel alloys are known as stainless steels. Stainless steels are corrosion resistant. They are divided into four groups: Martensitic, Ferritic, Austenitic, and precipitation hardening. Welding Martensitic steels. Martensitic steels are very hard and not very ductile. These steels can be welded using any of the arc processes normally used to weld steel. Post-weld heat treatment can be required to temper or anneal the weld and heat-affected zone. Welding Martensitic steels. Martensitic steels can be and often are welded using Austenitic filler metal. There are only a few electrodes available for welding Martensitic stainless steels. Careful review of the properties is necessary when using dissimilar filler metal. Welding Ferritic stainless steels. Ferritic stainless steels can be arc welded using all the processes normally used to weld steel. Preheating is normally not necessary except on some types and on thicker material. The heat-affected zone in ferritic welds is subject to grain growth, resulting in a loss of toughness. Shielded metal arc welding only has one ferritic stainless steel electrode. Welding Austenitic stainless steel. Austenitic stainless steels have very good strength and corrosion resistance at high and low temperatures. This illustration shows a weld in 300 series stainless steel. Welding dissimilar ferrous metals. There are many iron and steel fabrications that require welding metals together even though their compositions are different. It is important that the composition and properties of each metal be known. The filler metal used must be chosen carefully so the weld is at least as strong as the weakest base metal.